In this video, we're going to use the definitions of the 6 basic trig functions to evaluate the 6 trig functions for an angle in a given right triangle. So, here we go. I'm asked to identify the sine of theta, cosine theta, tangent, cosecant, secant, cotangent of theta, theta being this angle right here in this right triangle. Now in my right triangle, I'm given 2 of the lengths. I'm told that one of the sides is 3 and the other is 4, but the third side is missing. And in order to find all 6 of these trig functions, we need to know all 3 side lengths for our right triangle. So, you know how to find the third side of a right triangle using the Pythagorean Theorem. Since I'm looking for the hypotenuse, I'm going to take the square of the sides and add them together. So again, Pythagorean Theorem is a squared plus b squared equals c squared, where c is the length of the hypotenuse. So a squared plus b squared equals c squared. So I don't know what c is, but I'm going to solve for it. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. That all equals c squared. Well, if 25 is what c squared is equal to, I take the square root of that and I get a side length of 5. So I'll go ahead and label my third side length as being a length of 5. And that's my hypotenuse. So, knowing all 3 sides of my right triangle, I'm going to go ahead and identify the values of each of those 6 trig functions for that angle. So, the sine of theta. I bring SOHCAHTOA. SOHCAHTOA, so means opposite over hypotenuse. Well, the side opposite theta would be 3. And the hypotenuse would be 5. So 3/5 would be the value of the sine of theta. Cosine. So SOHCAHTOA. Ka is a over h. Let's see, that's going to be adjacent. 4 is the side that's next to my angle. That's my adjacent side. 5 is my hypotenuse. So 4/5 would be the value of cosine there. Tangent is TOA in SOHCAHTOA. So we're looking at the opposite side over the adjacent side. Opposite side is 3. Adjacent side is 4. 3/4 would be our value. Now, as we find the other 3, remember that they are reciprocals of the first 3. And I've got them lined up appropriately here. So the cosecant of theta would be the reciprocal of sine. So cosecant is going to be 5/3. Secant is the reciprocal of cosine. So 4/5 becomes 5/4. And finally, cotangent is the reciprocal of tangent. So 3/4 becomes 4/3. Now, one little trick as far as remembering, which one matches up with what. Well, tangent and cotangent, I think, are pretty obvious. They have the same word within them. Now, to figure out, okay, does sine match with cosecant or does sine match with secant? My little thought is this. The first letter doesn't match up. So sine doesn't go with secant, and cosine does not go with cosecant. Instead, we always take an S and match it with a C, or a C and match it with an S. Now, for me, I remember it because I went to high school at St. Croix. So I remember SC, St. Croix. That's how I know that these two match up. If you'd prefer to use one of your teachers, like you could say CS for Courtney Schmidt and remember it that way, that's great too. Whatever helps you remember which ones are the reciprocals of the others, great. We're going to do a similar problem here. Where we're given, again, a right triangle. We're asked to find the 6 trig functions for theta. Theta is now in the top right corner. Again, looking at the right triangle that's given to us, we only know 2 of the sides and not the third. So again, we're going to have to use the Pythagorean Theorem. This time I know the hypotenuse. So in my a squared plus b squared equals c squared equation, I know c and I know, we'll call it a. So I plug them in. 5 squared plus, I don't know, squared equals c squared. Well, 5 times the square root of 2 is the hypotenuse. I need to square that. Now, you got to be careful when you square this. First of all, 5 squared, well, that's easy. That's 25. So 25 plus b squared equals. Now, when I square this expression, this exponent applies to both parts of this product. So I'm going to square 5 and get 25. Make a little note of that. 5 squared is 25 times the square root of 2 squared. Well, the square root of 2 squared would be 2. So now, instead of 5 times the square root of 2 squared, I have 25 times 2. 25 times 2, well, that's 50. Now I continue to solve for b squared. Well, in this case, I'm going to subtract 25 from both sides, trying to get the variable by itself. B squared will thus equal 25. And now I'll take the square root of both sides and say that b is equal to 5. Well, in this case, normally when we take square roots in algebra, we have to put plus or minus in front of our answer. But realize that I'm talking about a distance, and I'm not going to have a negative distance or a negative side length in a triangle. So b is equal to 5. I'm going to go ahead and label this side as being length 5. Now that I've done the work to figure out the lengths of my triangle sides, I'm going to go ahead and evaluate my 6 trig functions. That was a 5. So here we go. The sine of theta is equal to the opposite over the hypotenuse. Opposite is 5. Hypotenuse is 5 times the square root of 2. 5 over 5 times the square root of 2. Now, there's some simplifying steps that we need to do here, but I'm going to save those until we have all 6 of these figured out. At least the first 3. So the next one, the cosine of theta. Cosine is equal to the adjacent over the hypotenuse. Well, guess what? It's the exact same thing. Now, one thing I'll let you think about, do you know what this angle is? I'm not going to tell you, but I bet many of you could figure out if this side and that side are equal to each other. I bet you know what the length of that, or the degree of that angle might be. Think about it. Let me know in class if you got it. Finally, the tangent is going to equal the opposite over the adjacent, so we're going to have 5 over 5. Now, we don't leave our fractions like this. This is not simplified, this is not nice and clean, so we're going to simplify each of these. Starting with the easy one at the bottom. Tangent of theta, 5 over 5, that's equal to 1. There we go, that's all I have to put is 1. Now, for cosine, let's see, as we back up this direction. First of all, as I simplify this expression, notice that I have 5 divided by 5. If I cancel that, I got 1. So now I have 1 over the square root of 2. Now, we've learned earlier in the year that you don't leave a radical expression in the denominator of a fraction. Well, here I have a square root or a radical in the denominator. That's no good. So I need to rationalize the denominator by multiplying both the top and the bottom by that same square root. So I've got 1 over the square root of 2 times the square root of 2 over the square root of 2. Remember, we do this because square root of 2 over square root of 2 is as if I am multiplying by 1. And when you multiply a number by 1, you're not changing the value of that number, you're just changing the way that it looks. So, to finish this off, 1 times the square root of 2 is the square root of 2. Here's my numerator. In the denominator, the square root of 2 times itself is just 2. A nice rational number, no more radicals in my denominator. So, this would be the value that I would want to write down for the cosine of theta, all simplified. Now, I'm going to just make this happen a little bit faster because I know that these two are the exact same. I know that this expression will also simplify to the square root of 2 over 2. So there's my first 3. Now, as I find the other 3 trig functions, remember that they're reciprocals of what I started with. I'm going to start at the bottom, again, because it's a little bit easier to go here. The reciprocal of 5 over 5, reciprocal of 1 is 1. That one's done. The reciprocal of the square root of 2 over 2. Well, let's back up a little bit. If I backed up here and taken 5 over the square root of 5 times the square root of 2 over 5, or even 1 over the square root of 2 flipped over. If I flip this expression over, I have the square root of 2 over 1. The square root of 2 over 1, I don't even have to write the over 1 part. I just write the square root of 2. Now, if you took the final expression, flipped it over, and simplified, I think you'd find that it would come out to be just the square root of 2, as you see here. And again, if secant was this, square root of 2, because that was reciprocal here, cosecant, sine and cosine mean the same value, cosecant is also going to be the square root of 2. And we'll circle all 3 of those. And there we have it. Now, we're going to do one more problem relating these right triangles and the values of sine and cosine. It looks something like this. So, if theta is an acute angle of a right triangle, and the sine of theta equals 4/7, what is the tangent of theta? I'm going to write that out a little bit bigger so we can look at it. Sine of theta equals 4/7, and we want to know what's the tangent of theta. Well, as I think about this, I've learned some things about right triangles. I'm told that this is an acute angle of a right triangle. So I'm going to go ahead and draw a right triangle as best I can. And I'll label theta as being this angle right here. So I know this. If the sine of theta is 4/7, that means that I've got an opposite side length of 4. And sine being opposite over hypotenuse, I know the hypotenuse of this triangle is 7. Well, if I'm looking for the tangent of theta, I need to know the opposite side, which I do, and then it's going to go over the adjacent side. Oh, what's the adjacent side? I don't know yet, but the Pythagorean Theorem will help me figure this out. So, in order to find the adjacent side, we'll call him A for adjacent. I'm going to use my Pythagorean Theorem and say that A squared plus B squared equals C squared. Well, that's my hypotenuse. So I plug in the things that I know. I'm going to solve for A. So doing a little bit of math here, 4 squared is 16, 7 squared is 49. A squared plus 16 equals 49. As I solve for A, I will subtract 16 from both sides. Close that off. 49 minus 16, well, that's going to be 33. A squared equals 33, which means that A itself is going to be the square root of 33. So I'll go ahead and fill in this side length as being the square root of 33. Now remember, I did this because I'm trying to evaluate the tangent of theta. Tangent of theta is equal to the opposite side, which is 4, over the adjacent side, which is the square root of 33. Now, as I look at, this was a multiple choice problem. If we go back and look at the 4 options, is 4 over the square root of 33 any of these options? No, it's not. And the reason it's not is because we need to simplify this expression. Right now, we've got a radical in the denominator, which is no good. So, like before, we're going to multiply the top and the bottom by that radical denominator. And what will happen is we'll have 4 times the square root of 33 for a numerator. Most of this stuff. And then we will have the square root of 33 times the square root of 33 is going to be just a nice 33. So 4 times the square root of 33 over 33. Let's slide back up to our possible answers. Oh, look at that. The answer is B.